And we are live. Welcome everyone to our webinar about load testing, one of our core services here at Cyrex. First of all, I would like to thank you all for joining. Over 900 people have subscribed to this webinar, so I believe it is safe to say that there's quite some interest in this topic. A big thank you to our marketing and sales team for setting this up and reaching out to all of you, but also to each and every one of you for being here with us today. I'm very excited to share our knowledge and unique insights concerning load testing and our Cyrex Swarm technology. So who am I? My name is Tim and I'm the CTO and co-founder of Cyrex. I'm 27 years old and I'm based in Belgium. I'm a very technical person. I have been working with computers since I was very little, writing my first scripts, websites, and programs at the age of 11. And since that moment, my knowledge and experience has grown tremendously. Within the IT field, I'm very passionate about gaming and everything related to it, ranging from game development till DevOps. Next to this, I'm also an experienced ethical hacker and security engineer. At Cyrex, we are working with a team of highly skilled technical people offering security and development services with a strong focus on the gaming industry. We are part of the Magic Media Group, which is a global game service provider offering technical and creative services towards the gaming industry. At Cyrex, we take pride in developing innovative products that help game developers and publishers, and our load testing is one of those unique products. And this is, of course, the topic that we will be covering today. Before we begin, I would like to ask you all to put your video settings on high detail. I believe you can change this on YouTube using the cogwheel at the bottom. In this way, you will receive the ultimate experience because within this presentation, we are using custom in-house artwork that we created, so it would be a shame if the quality would not be optimal on your end. What do we have on the menu for you today? First of all, we are going to be talking about load testing and what it is. Next up, we want to clarify some differences between load testing and stress testing and what you would need in which situation. Afterwards, we will dive a bit deeper in what load testing can do for you and why you would need it. We move on by looking into how load testing is done today and how we are handling things differently at Cyrex. Afterwards, we will start looking into our proprietary Cyrex Swarm technology and what it consists of. And last but not least, we'll cover a typical load testing workflow when testing a gaming title. Please stay with us as we'll wrap up this demonstration with a video of Cyrex Swarm in action used within an actual game. If any questions would arise during the webinar, feel free to leave them in the comments on YouTube. Our team will collect them and I'll try to address them and answer all of them at the end of the presentation. Thank you. Most of you probably already heard about load testing, and perhaps some of you have already conducted load tests in the past. But let's clarify first of all what load testing is. Load testing is the process of simulating multiple users accessing one application within a certain time frame. Generally, and in our case, we are talking about applications that connect to a server environment and allow access to multiple users. Think about games, software as a service platforms, e-commerce platforms, or fintech applications. Really, any type of application where you are expecting a huge influx of users. A load test is typically conducted in order to make sure that the quality of service for your users is guaranteed at all times. During a load test, response times are monitored. How long does it take for one user till he gets a reply from the server, as well as the usage of resources on the server. And we are mainly talking about CPU and RAM here. It is also very important to make sure that there are no errors occurring during high loads, such as preventing users to perform certain actions on the platform. A load test makes sure that your platform is stable no matter how many users are hitting your servers. You probably also heard about stress testing. So what is the difference between stress testing and a load test, and which one of these would you need in every situation? Let's look at some key differences for a second. First of all, stress testing is all about resilience, making sure that your application is operational at all times. It is focused on the network level rather than the application level. It is often also referred to as a DDoS simulation and consists of sending as much traffic as possible to a server to bring it down. Unlike with the DDoS, a distributed denial of service attack, where malicious users are trying to bring your application down as soon as possible, during a load test, you are assuming that none of the users have bad intentions. You take into account that all of those users actually just want to use your application like any other normal user would do. So during a load test, you want to simulate actual user behavior as closely as possible. In modern applications, a lot of different components and services are used. Just bombarding one of those services with a lot of traffic won't give you a realistic result, and you'll certainly miss something. Whenever you are then under high load in a real situation, maybe your database will go down just because it didn't get the same exact usage during the stress test, which was just focused on, for instance, bringing your web server down. So during a load test, you want to touch all services equally by performing calls and actions that the regular users of your application would also do. So what does a load test do for you? First of all, a load test simulates users. So during a load test, you want to simulate a certain number of users on your game of application. Generally, you want to define how many users you maximally want to simulate concurrently using your application. And this is based on the amount of users that you are expecting to be using your application at its highest peak. Think about a launch day or a specific event that you have planned. You need to estimate how many users you are expecting that will be using your application concurrently. And then you, of course, want to go for a worst case scenario. So you add, for instance, 20% on top of your estimation. And this is going to be the total number of users that we are going to simulate during our load test. The other important metric here is how fast are we expecting this increase in users. This means how many new users are joining our platform every second. If we are, for instance, talking about an online registration for a concert with limited tickets, think about Ed Sheeran, for instance, most users will be joining at the exact same moment in time. While if we are just talking about the launch of a new product, users will drop in more gradually. During a load test, you will also be able to measure how much resources are needed on your cloud infrastructure. In this way, we can measure during the time frame of the test how much this costed us. Multiplying this, you can easily know the exact cost for a certain event or for serving all of your users on a typical day. Having this knowledge and understanding can help you to understand which pricing model you can apply and how much money you need to charge your users in order to make certain profits on your product. On most of the load tests that we have conducted, certain errors pop up. Generally, you want to perform a load test on a stable platform, but we all know that quality assurance is not perfect, so sometimes a load test might uncover certain functionality that has a functional bug in there. But more importantly, if you are reaching certain resource limits, like CPU, RAM, or connection limits, the server will return an error to a certain amount of users. This allows you to address these issues and make sure your real player base will not experience this. Another common error scenario that is uncovered during a load test are typically race conditions. Race conditions happen when two or more users are performing an operation on the exact same time and disturbing the natural flow of this operation. Think about two users trying to buy the same unique item in a web shop, or trying to join a game match that only has one spot left on the exact same moment. Such race conditions can give one of the users a fatal error, causing his game client to crash, for instance, or stop working. During a load test, you will be able to discover such errors and address them before going live. Applying a certain scaling configuration is not an exact science. Based on the type of application, we will need to use various metrics in order to determine whether we need to ramp up our server instances or scale them down. A load test is able to test the effectiveness of such scaling configuration. What if we have a certain influx of users within a few minutes? Will our scaling configuration be able to scale in time? And what happens in the meantime? Will our users get a loading screen, or will they receive a timeout error and need to restart the application, potentially causing the same issue over and over again? If we measure how much servers we need in the game based on the amount of users that we have in the lobby, what would happen if most of the players are not in the lobby but playing a match? Will there still be enough servers the moment that the match is done and we want to start another one? A load test will uncover any of these blank spots and make sure that we can tweak our configuration accordingly. We all know that developers sometimes tend to take shortcuts in order to meet a certain deadline, but these shortcuts are not always the most performant solution. During a load test, you will get metrics about specific API calls or actions that are performed and what the response times are in those. In this way, you can uncover less performant functionality on a code level. Optimizing these calls will allow you to save server instances and thus money. This can also consist of architectural issues, like for instance, polling your service every 5 seconds from the client side to verify whether a match has been found will cause a lot more load on your service than having a WebSocket open that will inform the client side as soon as a match has been found using an observer pattern. As mentioned before, modern applications just consist of one big server hosting all the code and even the database. We are seeing a lot more microservices these days, talking to each other behind the scenes, written in various programming languages, and most of the time talking to different database technologies. Maybe you are using a relational database for one part and then a faster one for caching on or non-relational data. While your containers or server instances might scale perfectly, maybe your database is not scalable or doesn't allow for so many read and write operations at the same time. A load test will uncover these hidden problems behind the scene that need additional attention in order to make sure that the whole application is scalable. So what would be the main reasons to conduct a load test? First and foremost, you want to ensure a steady launch. Whenever you are launching a new product or game or a major new version with additional features that has been announced for quite a while, and probably your marketing team did a great job informing your customer base of your amazing new title. In this way, you can expect a lot of users to try it out on the launch day. This is their first impression with your product, and it should be flawless. Unfortunately, what we are seeing often is that the platform is not prepared for this, and there are lags on the end user side, making users leave and never come back. And those users might have actually liked your product. Another common example are certain events. When hosting a specific time-based event where you are able to win certain prizes, this will attract a lot of users in a very short time span. If they are then not able to connect or spin the wheel or whatever the concept is behind this event, your user base will get really frustrated and blame you as a company for not being able to obtain this special prize. Whenever you are growing as a company and your user base is getting bigger and bigger, you need to be ready to accommodate these additional users. If at a certain point in time your product is not able to handle the amount of users that it is receiving, this can be a hard limitation, and it can require quite some work from your developers or your DevOps team to fix these scalability issues, causing both issues for your users and a lot of pressure on your team to fix them in time. Your users will start to notice this degraded experience, and if you are in a phase of growth, new users that start to experience your platform will not stick around, and even a part of your already established user base might leave. So you want to make sure that you know about these limitations up front. You can still accept them, but then if you are reaching certain limits or certain numbers of users, it will allow you to respond in time and make the required changes before you are actually reaching this number of users. Like mentioned in the previous slide, a load test shows you how much resources you need to manage different amounts of users. Next to this, a load test also allows you to tweak and perfect your scaling configuration. By combining both results, you can make sure that at all times you have the necessary amount of instances ready, but also not too many. You are able to scale them up and down the moment you need them. So whenever it is night, for instance, and most of your user base went to bed, all servers should be scaled down to the bare minimum. And by applying such scaling configurations, you will be able to save a lot of costs as a company in the long run. Whenever you have a global footprint as a company and you are serving users from different continents around the world, you want to make sure that all of them get the same performance and speed when using your application or game. A user coming from America should not experience more lag than a user connecting from Europe. During a load test, you will be able to get in-depth metrics about response times of users all around the world. And in this way, it will enable you to apply certain changes, making sure that you have a cluster running, for instance, closest to their region. I'm just going to take a sip of water. Right now, I'm going to talk about how our current customers performed load testing before they came to us. It would be great to understand if and how you are doing load testing today. So feel free to leave it in the comments, and then we can address some of these examples during our questions and answers. The following topics might be a bit more technical, but I will do my best to keep it understandable for each and every one of you. It will only take a couple of minutes, so please bear with us. So what we are seeing often, and especially within the gaming industry, is that they are hiring playtesters all around the world in order to simulate the load on the server by real players playing the game. This option is generally opted because it is too complex to simulate the user behavior in a realistic manner. So companies hire players all around the world for a playtest at a very specific moment in time. Because your game is probably not released yet, this involves a lot of planning, contracting, exchanging NDAs with all those testers, etc. In the end, you'll probably be able to hire at best a few thousand players, but this is not going to represent your actual user base of players that are going to be playing your game. So it might uncover some low-hanging fruit, but definitely not all scalability issues. Next to this, you generally won't get decent metrics from the players that are testing your game. Sure, they can mention that they are experiencing some lag, but is this lag happening because the server is overloaded, or are they just experiencing some bad internet connection today? You are basically on your own and need to measure as much as possible on the server side, but this means that you can miss certain things just because you didn't have all the required logs implemented. Now, say that you have implemented all those logs and a lot of issues popped up during the load test. Your team starts addressing and fixing them, and at a certain point in time, they believe that they have fixed the scalability issues. But are they really resolved? Maybe they introduced another issue now. Are you going to plan another play event and hire all these players again? And how many times will you need to do this? Although this approach might be the most realistic player behavior, it is actually quite limited in both amount of players and flexibilities concerning retesting. Another common scenario that we are seeing in the industry to overcome the limitations from the previous solution is that the development team creates a modified version of the game client that is simulating the user actions that you want to cover during a load test in an automated manner. So we actually have custom game builds, like we are seeing on the left side here, that talk to live services over APIs or sockets, and then also to the actual gameplay using a gaming protocol over TCP or UDP. Implementing this botting behavior inside your game client can take quite some work from your development team. Taking into account that you are probably a few months ahead of releasing your title, your team is crunching ahead and they want to make their deadlines. So they might have different priorities. They might want to hunt down and fix some pressing bugs, or maybe there are still some new features that really need to be implemented in the beta version of your title. Next to this, imagine playing a PC game. Most of us probably have a beefy machine at home, specifically to play these games in a decent and flawless manner. Just because running a game client requires quite some RAM and CPU. Now imagine running a few thousands of those game clients. Sure, you are not going to run this load test locally. You will use a server farm to distribute these various clients across multiple servers, but it can become quite intensive and costly to run load tests in this manner. So how are we doing things differently at Cyrex? We are not going to use the game client. We will intercept the traffic that flows between the client and the servers, and then we will generate headless scripts that are simulating this user behavior and the common processes of a certain user, taking into account some semi-random behavior. This is a very similar process to what we are doing with our security teams, where they are intercepting traffic that flows between client and server, but in this case, in order to test the security, of course. But this makes a load test a perfect fit to perform during a penetration test, because then our team only needs to perform the research and implementation once. So these headless scripts will talk to your live services, again, either using API or sockets, and then as well to the gameplay services. We support any type of application or protocol and have a lot of experience with gaming protocols like Unreal Engine networking, Photon Bolt or PUN, ENET, you name it. In this way, Cyrex Swarm pushes past huge hardware requirements based entirely on the headless cloud format, which means that we have currently a capability of running up to 500,000 simulated users. There is no need anymore to hire people or to have intensive clients running on a big cluster of servers. And it gives you the flexibility to run testing over and over again until your scaling configuration is as perfect as it can be. So let's dive a bit deeper into Cyrex Swarm technology and what does it consist under the hood. First of all, we have a command and control server. This is the brain of the Swarm technology, and this is the server that is responsible for giving instructions to the various workers. It will tell the workers how much users we need, how fast we need them, and which specific code or actions the headless scripts should execute. Next up, we have a big pool of workers that are actually spawning the users, running the scripts, and simulating the user behavior. The amount of workers, of course, depends on the amount of users that we want to simulate. But since our scripts are very lightweight, we can simulate approximately 1,000 users on a single worker. This depends on the specific functionality that we are simulating, of course. The workers execute various actions onto your game server and receive replies back. The workers will then collect all of these replies, verify if any of them contains errors, and report all this data back to our data processor and visualizer. They will provide details about the errors that were encountered and will provide response times about each and every specific action that was performed on the game. It is then up to the data processor and visualizer to extract all of this data and combine it into useful statistics, like what is the average response time, how many requests did we perform, and how many of those failed. This server is also able to generate useful graphics out of this data, which can then be analyzed in order to solve any bottlenecks. Now we are going to talk about a typical process flow when it comes to load testing a game, and afterwards I'll demonstrate you Cyrex Swarm in action. So in a typical flow, we will start off by registering user accounts. First and foremost, because we need those accounts later on to start performing specific actions. So we will register as many accounts as users that we want to simulate. But a registration process also often involves mail service. And this is something that tends to fail often. Maybe you have certain limitations in how many mails you can send each day, or the mail server is not just prepared to handle this amount of traffic. As soon as we have registered these accounts and received all these mails, We will, of course, activate them to use them then later on and authenticate to your game server. So in the authentication process, we will use the credentials that we saved during the registration step, and we will get a certain authorization token back from your service. And as soon as we have this authorization token, we can then start performing specific actions on your APIs. For instance, one of the common things that we are testing during a load test is matchmaking. This because it has a direct flow, a direct connection to the amount of servers and game instances that you need to have ready for players to start playing a match. So matchmaking is really a valuable step to test in order to know if your scaling configuration is working correctly. So after we have performed this matchmaking and we get a valuable server back from your backend, we can then join the gameplay, and from this moment on, we can start performing specific actions within the game. So what does the results of a load test look like? First of all, we will have different metrics and statistics. What are we seeing here? We are seeing the same flow that we had on the previous slides. And first of all, we are seeing the registration, account activation, and login step. And we can see that we performed 175,000 requests. So we are actually simulating 175,000 users in this specific case. Next to this, we are reporting if there were any failures. Failures will always come with a certain error message, and we will dive a bit deeper into common error messages in the next slide. We can also see various response times. We see the average response time here, the minimum response time, and the maximum response time. This can give us a good understanding of how fast the server replies. And then we also see the average size in bytes of the response. There is a clear correlation generally between the average size in response and the response times. The bigger the response, usually also the longer it takes for the server to reply. We are also seeing the requests per seconds that we performed and how many failures that we had per second. After the login, we are performing a call to the backend. And we are requesting a match ID from the backend. This process happens in a loop where we are starting this over and over again because maybe there were no issues in the first cycle and everyone found a match and could join this match. But then if everyone ends his match and the players start joining the match again, maybe in that at that moment there are not enough servers available anymore. So it's very important to always perform this a few times. And then in this specific case, we need to poll the backend service to see if there is a match found. So this is the find match server, and we are polling every 5 seconds in this case to know if a server has been found. We are seeing some fails here. Those are probably backend errors. Maybe the server got polluted, so we will look into that later. And we also have a metric underneath that shows how long it took to find a successful match server. So in that case, we are again seeing fails. This means that some users did not find a successful match server and were stuck in the lobby. And we can also see that the average time to find a match was about 34 seconds, which is quite long in my opinion. And then if we look at the maximum response time to find a match, it even lasts 280 seconds. The users that did find a match will then connect to the game server, and in this specific case, we are talking about Unreal Engine 4 network traffic. From this moment on, we are able to perform specific actions within the game. We can also plot any of this data onto a graph. So in this case, we are seeing a graph of one of the specific actions. And we are showing two lines here. We have a green line, which shows the median response time, and then we also have a yellow line, which shows the 95% worst response times. Why not take the absolute worst response times? There can always be a certain hiccup in traffic. It's not 100% guaranteed. So you want to take this 95% to really get an accurate metric of which users are really experiencing issues. And then we can see two spikes on this graph. So the first one, when we are building up in amount of users, we can see that both the median response times go up till 10 seconds, and also the yellow line goes up until 25 seconds. Then the service starts scaling, and the response times tend to drop. But then there is a second spike because the service didn't scale in time. And in this case, most of the users, the median response time, the green lines stay more or less the same, but we can see that the yellow line still again goes up till 25 seconds. And we can, of course, help your team together and discuss how we can address these issues. So what are some of the common errors that we are seeing when conducting a load test? One of the main errors consists of 502, 503, 504, which basically tells you that the service is no longer available. In this case, it tells us that the backend server is at full capacity. This is probably a load balancer that is in front of your server that is replying this back to us. And it then comes down to start diving into the specific servers or containers to look at logs. Maybe there is no CPU left, maybe there is no RAM left. Generally, this is the case in case we get such error. Another common scenario is that we have a 500. This is an internal server error that generally happens on the application level, where the application is getting an error because of certain behavior. In this case, we can read that we have a database connection error and that there are too many connections towards the database. It then comes down to either increasing this limit and allowing more connections to the database, but then we also need to make sure that the database is able to handle those connections. Or we can look into our code and reduce the amount of connections that we are making towards the database. Then we have an error that some users did not find a successful match after 500 seconds. We will always mimic the behavior of your game client here. So if your game client waits for 500 seconds to join a match and then give up, then we will implement the same behavior within our headless scripts. And in this case, 500 seconds is quite long, but even after 500 seconds, some of the users were not able to find a match. And then the last one is specifically when joining a certain game, we get a reply back from Unreal Engine telling us that the server is full. And this is actually a race condition that we are sometimes seeing where there is only one spot left within the game. Two users try to join this match at the same time, and one of them will, of course, get a reply that the server is full. I'm now going to demonstrate our fully custom developed load test for this webinar. This is footage of an actual Unreal Engine game that we are using in-house to test new features of Cyrex Swarm. You will be able to notice that we are quite a fan of zombies here at Cyrex. So what we are seeing here is that zombies are spawning in this underground world, and these zombies, of course, they represent actual players or characters within your game. and our Cyrex Swarm technology is spawning them until we have a lot of users within your game. So this will be similar when it happens within your game. And in this specific case, we are sending then a request to our game server for these users to start performing a dance move. This can, of course, be anything that is applicable to your game. Maybe you want us to transfer a certain item from the inventory, because then we are talking behind the scenes to the inventory service, or you want to perform a simple quest, and in that way we are contacting the quest service. You want to cover all services that you have within your game, but generally you don't want to perform each and every single action within the game. If you want to know more about Cyrex or about load testing, please visit our website, www.cyrextech.net. There you can find videos. We had a previous webinar, The Art of Game Hacking, a couple of months back. So if you're interested in security within games, please check it out on our website or on YouTube. We write weekly blog posts about topics that are interesting to us and maybe as well to you. You can also find a portfolio on our website where you can see the customers that we work with, and you're also able to download an anonymized load testing report there, and in that way you get a good feel about what the results are of a typical load test. Also feel free to connect with me on LinkedIn or send me an email, and I will be glad to answer any questions that you still have left or to discuss certain topics. Thank you. So first of all, during the presentation, I asked you how you are doing load testing right now. If you have not done so already, please share your answers right now in the comments. And in the meantime, let's see if there are already any questions from the audience. So one question is, what do you do when you are receiving a 500 error? Can we wait and maybe run the test later on? Definitely. So if we are encounter functional 500 errors, we will always check back with your team, of course. Maybe we are doing something wrong there, and we need to adapt our scripts. If it's something on their side, they can then patch it and we can run it again. But because we are not using actual users, we can run this test at any point in time. So if you are having certain scalability issues, we give you certain insights, you fix them on your end, and then we run later on again up till the point that everything is fully fixed. This is how we work. Another question from the audience: what is the largest load test you have done so far? So I've mentioned that our current capacity is half a million users, so this is 500,000 users. This is what we have done so far and that we know that we can handle. This is not a hard limit. I'm pretty sure that we can go beyond this, but so far this is what we have done, and that was giving reliable results. Another question I'm reading here is, are these real or virtual servers? Now, I'm not sure what the context behind this question is or what moment it was asked. I believe you are talking about the workers here. Those workers are not real servers. They run virtually within certain containers, and we use, of course, certain Kubernetes scaling configuration to scale them as well on our end. Developing this proprietary Cyrex Swarm technology has been, for us as well, a real challenge to make every component within our Cyrex swarm scalable as well, because it needs to be twice as scalable as whatever we are testing, basically. Another question that I'm reading here is, do you also load test on applications that are not games? Definitely. So it's not just games. This is, of course, very interesting towards games, and we have a strong focus on games, but we have done load tests for various different other applications, ranging from e-commerce platforms till software as a service platforms, fintech applications. So yeah, just hit us up with your application, and I'm sure we can help you out. At what stage is it the best moment to conduct a load test? Well, the best moment is, of course, whenever your product is already stable and there are not a lot of changes going on. So generally, it happens at the end of your development life cycle. I would say a few months before you go live with your product or in beta with your product, you want to conduct a load test. And not just a few weeks, because you still need to patch, of course, the issues that are encountered during the load test, but a couple of months before you go live is the best time, I would say. Another question, so many 500 and 502 server errors, any specific reason? Well, basically, whenever you start encountering 502s or 500 errors, you will encounter a lot of them. So once your servers are polluted, a lot of users will start to experience this and will get blocked. So the moment you have them, it is really down for everyone, I would say. So how can you fix them? 502s are generally related to CPU or RAM limitations, and then you need to scale your container servers, whatever you have, or increase, of course, the amount of CPU and RAM that they have. If we are talking about 500, then it comes down, of course, to the specific error that is reported back to us or on the server side, if you are not disclosing errors to your end users. And then it's generally, yeah, it can be multiple reasons. It can be a race condition like mentioned, or it can be some other service that they are talking to that is polluted or has certain limitations. Let's take one last question from the audience. So the last one is, how long does it take to conduct a load test? The load test itself, you generally want to run for 20 minutes, half an hour. This is generally an accurate time to perform the load test. The full cycle of conducting a load test, I would say, yeah, you start off, of course, by implementing all the headless scripts. So this depends, of course, how big is your application, how big is the scope that you want to have tested, and then how many iterations are there. This really comes down towards how scalable are you already. We have seen customers where with just 2 or 3 runs and everything is perfect, and then for others it can take a couple of 100 runs. But in any case, we are here to assist you, and certainly within a few months, it is possible to address all the issues. So thank you for being here with me today. I would love to see you all on our next event, which will be in 3 months. So please follow us on our socials, and we will stay in touch and let you know what this next event will be about. Thank you very much.